All right, so what I'm going to do, I think, is run through several examples of a hypothesis test and see if we can sort of get up to speed on the process. So, what we have here is in very bad handwriting. It says an exam is given to 60 second graders, and the scores x bar equals 52 and s equals 15 are obtained. And the question is this: do these data support the hypothesis that the mean score of the second graders is greater than 50? So do these data support the hypothesis that the mean score of the second graders is greater than 50? Now, again, when you do hypothesis tests, every time you go through the 5 steps. You don't just start randomly writing things all over the place. You go through the 5 steps from Dr. Biersman of hypothesis testing. The first one is formulate the hypotheses. So we have the null hypothesis and the alternate hypothesis. And remember, the null hypothesis involves equality somehow. The alternate hypothesis must involve inequality. Very often, but not always, this problem is stated from the perspective of the alternate hypothesis. And I think that's what we have here. So it's just read it and write it. Do these data support the hypothesis? So here it comes. Support the hypothesis that the mean of the second graders. Now, in the hypotheses, never, ever put X bar in a hypothesis. Never put X bar in the hypothesis. This is the population mean. And the question is, the mean score is greater than, now this shouldn't be too hard to figure. Is greater than means is greater than. 50 means 50. So it pretty much is read it and write it. And in the work that I'm going to have you guys do, it's going to be very straightforward, very even-handedly stated. We have the mean is greater than 50. Now, if this is mean is greater than 50 is the alternate hypothesis, then we know what the null hypothesis must be. It must be the opposite. If this is greater than, this then must be less than or equal to 50. So these are the hypotheses we have. Number 2, we need to determine alpha. If there is no alpha given, then we know what to use for alpha. If there is no alpha given, we will use alpha equal 0.05. All right, number 3, we need to gather or garner all the data. And so we have 60. 60 is the number of second graders. X bar, this is the data we got from the sample. And the standard deviation, sample standard deviation is 15. From that, we can compute the z-score. I'll compute it down here, or the t-score rather. The t-score is x bar minus mu subscript 0 all over s over square root of n, and degrees of freedom are n minus 1. Have we met the sufficiently large requirement? Yes, our sample size is 60, and so the sufficiently large requirement bell has been rung. We need now to just substitute and simplify. So x bar is 52 minus, what do we find here? What is the subscript 0? Subscript 0 means that is the value from the null hypothesis. Subscript 0 means it comes from the null hypothesis. So that's 50 over, and then we need s, which is given to be 15, and the square root of n, which is given to be 60, and the degrees of freedom are 60 minus 1. We have 59 degrees of freedom. And I'm going to get my calculator and do this computation here. So let's see if I can pull this up here. So this implies t is equal to, we have degrees of freedom already at 59. So I'm going to do open parenthesis. Again, you should do parenthesis around the numerator, parenthesis around denominator is a straightforward way to do this. Open parenthesis, 52 minus 50, close parenthesis. Divide by, open parenthesis, 15, divide by the square root of 60, close parenthesis, and I have 1.0327. I'm going to round this to 3 decimals, 1.033. So my t-score is 1.033. Just to be sure, I'm going to double check that. Open parenthesis, 52 minus 50, close parenthesis. Divide by, open parenthesis, 15, divide by the square root of 60, close, and I have 1.03, approximately 3. So 1.033 is the value I'm going to be using with my 59 degrees of freedom. The next piece is we need to find the p-value. This is step 4. One of the reasons I have you go through 1, 2, 3, 4, 5 is you get finished with this step and you say, okay, where am I? What am I doing? Where am I? This allows you to get your bearings back. You just completed step 3. That means you go on to step 4, and now you're back on track again. So the step 4 is the p-value. And so we need to find in the 59, count them, 59 degrees of freedom row, we need to find the 2 values between which 1.033 falls. I want to write this up here so we can see it maybe a little better. This is my step 4 p-value. And I need to find the 2 values between which 1.033 will fall in the 59 degrees of freedom row. And my value falls between can you find it? 59 degrees of freedom, the value between which 1.033 falls. I have that's between 0.848 and 1.046. 0.848, 0.848, 0.848 is less than our value, 1.033, which is less than 1.046. This shows why this last decimal approximation is not such an important piece. All we need to know is the 2 values between which that falls. Now, the numbers at the top or bottom, if your table is so wonderfully designed, the numbers at the top of those columns in the 59 degrees of freedom row, numbers at the top or bottom of those columns is 0.20 and 0.15. So 0.15, 0.20. So the 0.848, that falls between 0.20 and this falls between 0.15, and this is the p-value we want. All right? This is the p-value we want. And remember our rule, you reverse the direction of these inequalities. So we need to find where in this inequality string, this is our inequality string, we need to find where in this inequality string, where does alpha fall? So where? This is 0.0. Again, think of this as 5%, think of this as 20%, think of this as 15%. And the question is, where does 5% fall in this inequality string? Papa bear, mama bear, baby bear, we need something even smaller. We need little embryo bear, 0.05. So our alpha value falls way over here to the right. Our alpha value is way over here. So we have 0.15 is greater than 0.05. This is the value from here, and our alpha value is 0.05. And then here's, let me write this. Get some more space. 0.20 is greater than the p-value, which is greater than 0.15, which is greater than 0.05. So the question is, so this is where alpha falls in this inequality string. Is the p-value for decision rule number 5, the decision, is the p-value less than alpha? This is by far the trickiest bit, and I've done kind of a bad job of this here. So I'm going to clear this out a little bit and go over this a little more slowly. So, step 4, p-value. We have 59 degrees of freedom. We need to find the two numbers between which our t-score was 1.033. So we need to find the two values in the 59 degrees of freedom row between which this falls. In the 59 degrees of freedom row, that falls between, I'm going to suppress the 0 point. I'm going to say it falls between 0.848 is less than 1.033, which is less than 1.046. So our value falls between these two numbers in the 59 degrees of freedom row. The next piece is look at either the top or the bottom of those two columns. Then the number in the margins is 0.20 and 0.15. This number, the number we computed, gives rise to the actual p-value. So we don't know precisely what our p-value is, but we do know it's somewhere between 15 and 20%. And remember, small numbers here correspond to large numbers here, and large numbers here correspond to small numbers here. The direction of these inequalities must be reversed. So this is our range for the p-value. The question now is, into this sequence, into this string, biggest, middle size, smallest, Papa bear, Mama bear, baby bear, into this string, we need to insert our value of alpha, which is 0.05. 0.05. Well, where does 0.05 fall in this inequality string? Again, think percent. We're going to write decimal, but think percent. This is 20%. This is something between 20 and 15. This is 15%, and we want 5%. 5% falls way over here to the right. This is alpha. So now, this is all we need from step 4. Step 4 is we would need to find the p-value, and this is 0.20 is bigger than p-value, which is bigger than 15, which is bigger than 0.05. Papa bear, Mama bear, baby bear, little baby embryo bear. And so now, step 5, all we need to know is the p-value less than alpha? This is the decision rule. So we have p-value. And every time you write this out, every time you write out p-value and alpha, p-value and alpha, p-value on the left, alpha on, no matter what you get here, put p-value and alpha. The question is p-value, Mama bear, how does that compare in size to alpha, which is embryo bear? Well, pretty clearly, p-value is greater than alpha. And what is our decision rule? What is the decision rule? And if you can't smell a multiple choice question happening here, you're not sniffing very hard. What is our decision rule? Our rule is reject the null hypothesis if the p-value is less than alpha. Reject the null hypothesis if the p-value is less than alpha. That's why we don't need to know specifically just how do these numbers compare. Reject the null hypothesis if the p-value is less than alpha. Our p-value is not less than alpha. So we do not reject the null hypothesis. And a couple last little details regarding this last little piece of information. Step 5. The decision is always made in terms of the null hypothesis. The decision is never, ever, ever. The decision is never made in terms of the alternate hypothesis. If you ever put H sub 1 in your decision, that is wrong, wrong, wrong. The decision always references the null hypothesis. And there are two choices and two choices only, and anything other than these is right out. One possibility is reject the null hypothesis. If we had gotten p-value less than alpha, then your decision would have been reject the null hypothesis, the end. But we got p-value greater than alpha. And so then your decision is do not reject the null hypothesis. Some places it'll say fail to reject null hypothesis. Fail to reject and do not reject mean the same thing. It's much more straightforward to simply say do not reject the null hypothesis. For our purposes, with this abbreviated semester, that's the route we're going to take. All right, so that was kind of a long go through. What I'll do next is pick up another couple of problems and work through them with a little bit less of the exposition and a little bit more of just the demonstration. So what you'll do is I'll put a new problem up here on the next video and see if you can work the thing out, and then I'll work it with you and see if we can figure out what's supposed to happen.